Hi, welcome back. We're continuing to talk about properties of exponents, and in this video, we're going to look at different bases. So I have a couple examples here. The first example I have is 2 times 3, the quantity squared. So based on this rule, I should be able to take this squared and distribute it in to each of these terms because I have multiplication. So this should become 2 squared times 3 squared. And I know that 2 squared is 4 and 3 squared is 9, which is 36. So I end up getting 36. But I want to make sure that that makes sense, so I want to think about this a little bit differently. So if instead of distributing this in, what if I first multiplied them? So 2 times 3 is 6. 6 squared is 36. So this ends up checking out and I get the correct answer. So I want to look at this problem here, 2 plus 3 raised to the 5. It looks very similar to 2 times 3 squared. These look almost identical, right? The only difference is that this is multiplied and this is added. This falls into our case down here, that a plus b raised to the m is not equal to a to the m plus b to the m. So that means that this is absolutely not equal to 2 to the 5th plus 3 to the 5th. And I'm going to show you why that is true. I'm actually going to pull out my calculator here and I'm going to go through this math. So I know that 2 plus 3 is 5. So this becomes 5 to the 5th. So let's actually use my calculator, 5 raised to the 5th, and I get that that is 3,125. Okay, so I went to my calculator and I used that. I'm now going to work this direction. So 2 to the 5th, I know that that is 32. And 3 to the 5th, I'm just going to go to my calculator for that. Let's just check 2 to the 5th. It is 32. 3 to the 5th is 243. All right, so 32 plus 243. Adding those together, I get 275. These are absolutely not equal. So this is numerically why this doesn't work. We would need to end up foiling this out, and this is to the 5th, so this would just become a nightmare. But keep this in mind, addition versus multiplication. Make sure you're not getting them confused. Moving on to this example, let's kind of take this 3 and we get to distribute this into all of the terms in there. So that's what I want to do first. So this is going to become 4 cubed times x squared cubed times y to the negative 1 cubed divided by z cubed cubed. Now I'm going to, so I've dealt with this different base. I've distributed the exponent in. Now I need to work with this power rule. So I have 4 cubed times x raised to the 2 times 3 times y raised to the negative 1 times 3 divided by z raised to the 3 times 3. So I am going to simplify that down. 4 cubed, x to the 6, y to the negative 3 divided by z to the 9. And now I notice I have a negative exponent, which means this is in the wrong spot. I need to move it down to the denominator. So 4 cubed, x to the 6 divided by y cubed, z to the 9. And I'm going to do one more step, which is 4 cubed. 4 cubed is 64. So 64 x to the 6 divided by y cubed, z to the 9 is my final answer.